Okay, so this was the excuse me, this was the example. Load was given here in the roof. Dead load was 20. If you can remember, 20 psf. Snow load was given 40 psf, and in floor means here and there. uh, Dead load was given 40 psf, and live load was given 50. Same thing here also. So what we did at first, we then what are the spacing was 18 feet, 18 feet square. That means tributary area for each column, this column or even this column. So tributary areas for 324 square feet. How it came? 18 times 18, 18 times 8. Then after what we did, this was live load. Excuse me, live load in the floor. So we know that we can decrease live load based on the tributary area. Then for this column, we will consider this floor, and we can determine that our that was the equation 0.25 15 KLLAT. After this equation, we found, can you remember, 33, 34 something, 33 point something, or we can do it very quickly again for a revision. So this is 50.25 15 4 324. Okay, so 0.25 plus 15 divided by square root 50 square root, then what, square root, then 4, then 324.67. Yeah, so 0.67, it is more than 0.5. So this portion is more than 0.5, that means good. For single story, minimum should be 0.5. Or something else also to tell you, this equation is in your FE exam handbook, so it is important to understand this equation. Okay, so 0.6.
If we come up with an answer that's less than 0.5, do we just substitute 0.5 in there?
Your question is, if we find, say it is 0.33, what to do, right? We will take this one, 0.5.
Thank you.
Yeah, no problem. So if we get this number less than 0.5, we will not take it, we will take 0.5, and that means will be 25. For our case, it will be 33.33. So 33.33 psf for this floor. For this column, very quickly again, this column will take load from here, will take load from here, double. So for this column, our live load will be same thing, 0.25. Oh, 50 actually here, 50.25 plus 15, 4. Here is the key point. What is the tributary area? Because both floor, this floor and this floor, both. So 2 times 324. That is something like I was telling last class, this class again, because it is very important in FE exam. Only calculating this is a very good question. Okay, so 0.25 plus 15 divided by square root and 4 324 times 2. I got an ugly number, so maybe wrong. Let me do again. 0.25 plus 15 divided by square root 4 324 2. Yeah, this time I got 0.54. So 0.54. When a column will take load from multiple floors, so this is one floor, second floor, multiple floors, that time this value can be 0.4 minimum. It is in your book. Sorry, but it is 0.54, so we are good. Okay, 0.54 times excuse 27.23, so 27.23. Yeah, we did this portion last class. Again, I revised it because this portion is very important for your FE exam. And also last class, after our memory typically or our attention does not work good after 50 minutes. This is a I revise whatever we did last class. uh, oh, this is something to tell you. Academic hour is 50 minutes. The reason is this. Based on research, we found that, not we, the community found that after 50 minutes, people lose their attention. They cannot attend on something. This is why the academic hour is 50 minutes. Okay, so okay, we found it. Now, what was the question? Question was telling calculate the cumulative axial load on typical interior column without live load reduction and with live load reduction. Or simple, if this is the load, whatever load given here, whatever load given here or in the roof, calculate the load for these two columns, the design load. Simply, this is the question. If this is the load in this structure, what is the design load in the column? That's it. And why do we need load? Because to design column, load calculation is the first step. Without load, we cannot design. Okay, so I will start the what is that? Load calculation. Okay, so I will go to new slide. If you took it, good. If you did not take it, I'm taking the video. You can take it again. Okay. Oh, I forgot everything. Okay, no problem. I can remember, but it is better to draw this column, this structure again. Yeah, I see that you do not like to draw something in your homework, exam, or anywhere. Always draw. If you draw, you can remember, or it gives better understanding. So we learn this, and then in this column, our live load is how much? 27 psf, and dead load is 40 psf. In this column, our live load, I messed up. In this column 27, in that column it is 33.3. In this column 27.2 psf, and live dead load is 40. Yes, so far I can is it right? Yes, I can remember now, but both are 40. Let me, yes, it's snow load 40, dead load 40. It is correct. And live load 33, live load 27 is correct. I can remember now. Okay, now what we will do? We will make a table. If you make a table, it is better to feel like what we are doing. So this is our, so first is our roof column. Roof column. Roof column means the first top one. This is roof column, the top column. Then second story, then first story column. Okay, then we will summarize our load here. Dead load, it is 20, dead load here 40, dead load here 40. It is PSF. Then uh, snow load here, 40, or right here simply live load. So for roof, it is actually snow load. By live load, we mean snow load here. Or we need to make another column. How to make another column? Simply light here. So L is 33.3. Here L is 27.2, if you can remember. And what is this portion? This portion is PSA. Okay, then our tributary area. Tributary area for everything is 324. 324. I know that you might have a question here. Why tributary area is 324 for all the columns? For first story, we just used double of this. Yeah, that is the summation of all the tributary area for load reduction. For normal tributary area is 324, and that when we multiply it by 2 in the base column for tributary area, that is for load reduction. Okay, now what we will do? Now we will do load combination. Now load combination 1, I do not need to do it because I know that load combination 1 will not win. I will do load combination 2, and I will do load combination 3. Load combination 3. Question is why load combination 2 and 3 only? No, why not 1? Why not 4, 5, 6, 7? Because when the load is only dead load and live load, then it is combination number 2 that will win. When the load is dead load and roof load, roof means snow, rain or roof live, then combination number 3. When there is a wind, then combination 4, 5. When there is a earthquake, then 6, 7. We already memorized it. So ideally we should try all 7, but as we became smart by this time, we'll do only whatever we need. Okay, load combination number 2. What is that? If you can remember, it is 1.2D, 1.6L, and then 0.5 say snow. There's no other load, so I am writing only snow, nothing else. So for roof, 1.2D, D means 20, there is no L, so zero point 0.5 times snow, it is 44. So we got this value 44. Now for in this case, second story, 1.2D, D means 40, plus 1.6 L, L means 33.3, and there is no snow. 101 say 3. Make sure that you're understanding this 44 1013, because this is the main part of this example. What I'm doing, I'm just using this equation 1.2D, 1.6L, 0.5 S. And for second story, third story, there is no S, only L. Okay, then first story, 1.240 plus 1.6 live load 27.2 and no snow. So here I got 91.5. Now combination number 3. What is that? It is 1.2D, 1.6 S plus 0.5 L. So 1.2D, D means 20, 1.6 L, sorry, S means snow, 40. So we got here, we take a new color, we got here 88. Now if you are smart, do you need to calculate here and here? I do not think so. That will not win. But still though, do it. So that will 1.240 plus 0.5, 33.3, 64.7, 64.7, 1.2 times 40, If you are doing with me, you will understand better, or make sure you understood all the values. It is not magic, I'm just calculating using my calculator. Zero point 0.5 live load, 61.6. Or again, what I did here, I just use this equation. Use this equation, that is load combination number 2, load combination number 3. Now somebody might say that, oh, I am not getting it. In that case, what will happen? If you use a latest version or a old version, this coefficient in the combination may change. So this combination is not universal, it will change with time. So no worry, as long as you are following uh, the equation or the procedure, then you are good. Even in your career, so your career will be say 30 years, 40 years. So at the beginning, you will start with one coefficient. After 5 years, another. After 5 years, another. The specification will revise it again and again. Okay, then what to do? Oh, then okay, I will change my color. Uh, go, go, go. Now, so now we are assuming that we did all other combination number 1, 4, 5, 6, and 7. After doing this, we should take the another problem. I need to delete all this and some space. Is there any faster way? Okay, hopefully it should be good. Or maybe delete more. Uh, okay, so we got this. Okay, then what we will do? We will take the, after doing all the combination, we will take the highest number. Highest number. Oh, say highest number here is 88. Highest number here is 101.3. Highest number here is 91.5. Highest of all the combination. Highest of all 7 combination. Now why we did only 2? As I told you, I know that when there is dead load, live load, these 2 will be the critical. Okay, now this load is in PSF. If you can remember, PSF, pound per square feet. Then we will multiply this load using this tributary area. Then what will be? We will get the load in pound or kip. Let us do it in kip, kilopound. So what I am doing here, 88 times 324 is, okay, take a new color. So I got 28.5. Where I got it again? 324 times 88 is 28512 pound. I divided by 1000 and I got it 28.5. Same thing here I am doing 101 times 324. 101.3 plus 324, 32.8. Actually we should round up. I am rounding 8. We should use here 6, use here 9, but again that is okay. 91.5 times 324, 29.7. 29.7. Now where I got 29.7, 324 times 91.5. Now somebody may ask me question that why it is 324. I am telling again, we used double of this when we reduce the load. Now we are not reducing, we are just uh, taking my floor. that, that cumulative summation is for load reduction. Now, then other question is, if I multiply 324, that means I'm only considering this floor, but this column will take load from this floor and the roof. Yes, we will add all this. So after this, we will take sum up all this. So if I sum up all this, I'll get my load in the base column. And if I use a new color, what color is left? Almost we used all color. Okay. Now if I sum up these two, we will get load here. So now hopefully you understood clearly. Yes. When we will design second story, then we will sum up these two. When we will design base, we will sum up all three. When we design only the roof, then only roof. But other question somebody may ask you, I know that. In a building, will these three column will be defined in cross section? It is better. If you do that, then what will happen? You can save some money. Less material, less section, less dead load. At the same time, if you change your section every floor, you have to do connection. That is another problem. So it has a problem. It has a like advantage, disadvantage both. But only for three-story building, I will say no. Use only one section throughout the entire three-story. If the building is say 10-story, then I will say no. It is if you continue the same section throughout the 10-story, it is over design or wastage of money. So in that case, you can do three-story one, other three another one, other four another one. You can do this way gradually. But in this problem, the question asked us only the base column. So we'll sum up all this. 28.5 plus 32.8 plus 29.7. 91. Okay. So if I use a new color, this column is taking 91. Keep. And the second one, 28.5, 32.8. This one is taking say 60, round up a little bit, 62. I got 61.3. I gave 62 because we already lost some when we came up this 32.8 or 25.5. There are some fraction. Okay, and the roof is obviously 29 kip. So hopefully you understood how we calculated the load. Okay, in your previous class 316, column frame load was given. Where the load was given, actually they calculated this way. This is the way to calculate load. Now, so this example is done, but in this example there's other part. If you see it, calculate the cumulative axial loads on the typical interior column with and without live load reduction. So what we did live load reduction. If you want to do without, that means you will not reduce it. What to do? Simple. Your this L will be 50. This L will be 50. If you do not reduce it, that is the only change. Now, do we need to reduce? Yes. If you are sincere to your client, if you want to save his money, you will reduce it. If you want to save your life, that I will not do many work, I got a very small salary, I will just design whatever is easier for me, that time you can take 50, no problem. And if you take 50, it is not wrong, it is just over design. You did not save some money to your client, that is it. Okay, so hopefully you understood. I will make a homework based on this. No, it is like killing you. I think you understood this example. Now, so this example is actually done. Do you have any question on this example? Is very good example for your real life if you want to be a design engineer. Okay, so no question.
I have a question about the formula.
Okay, 1 minute. I cannot hear you better, so let me increase my sound. Oh, my sound is the highest. Okay, now tell me, please, Andrew.
I just, as I was looking at the book, the formulas that you wrote in the table for low combination 3 doesn't match the one in the book. Is that, am I looking at that wrong or something?
No, no, no. As I told you, it depends on which edition you are using. If you use the latest one, may be different. Even after 5 years, this coefficient will change.
Okay.
So this I
So
say,
when,
okay, yes, do not take it personally that it is wrong. No, everything is right as long as the procedure is good. I am following edition number 1. The reason is I have the soft copy.
so when we do our homework, just use the formula that's in our the latest edition or whatever we're using.
Yes, yes.
Okay.
No problem. I know that there is some sense. I already know it. So in my book, let me check again. No, you are right. Even in combination number 3, this book uses no point 0.5 here. No point 0.5 here. But I know in some edition it is 0.5 there. So if it is not 0.5 here in your book, no problem. Whatever in your book, just follow that.
Thank you.
No problem. Okay, then what I will do, I will go to our next concept, which is, so in the, okay, I will summarize. Before that, let me stop.